Welcome you all my lecture series of operating system. In this lecture video, we are going to see about one of the memory management concept like swapping and contiguous memory locations. So in the previous video, we have seen what is a memory management activities in terms of operating systems. That operating systems activities are we are going to allocate and deallocate the memory, and we do the swapping concept and also do the efficient memory storage techniques. So in this lecture we are going to see about the topic like what is the swapping and what is the contiguous memory location, that is what is the partitions of fixed and continuous memory locations, and how the dynamic memory allocation techniques are used in the continuous memory location. First, we will see that what is a swapping. So swapping is a mechanism in which the process can be swapped out from physical memory to the secondary memory, and swap in from the secondary memory to the physical memory at the time of demanding that particular page. So the swapping is done between that physical memory to secondary memory. That name is called it as a swap out. So and physical secondary memory to the physical memory is called it as a swap in. So why we need that swapping means at the time of execution, if any page is demand means we can because the physical memory size is very less, we cannot store all the coding, all the program in the single physical memory. So at the time of execution we can brought that coding set of code into the secondary to the physical memory. So the benefits of swappings are it provides a high degree of multi-programming, so more number of programming can utilize the memory efficiently, and it provides the dynamic memory allocation and better memory utilization, and also it reduce the CPU compaction, CPU time on compaction, and it can be applied on the priority based scheduling processes. Suppose some process is executing, so if highest priority process is enter into that need to the CPU, means that currently executing process is preempted and highest priority process is using that physical memory. So that is the thing began in the concept of swap. So next we will have the different types of memory allocations, that is a continuous and non-contiguous. In contiguous memory allocation, we have a variable partitions and fixed size partitions of the physical memory. So the main memory is an accommodate both the OS and the various user processes. So the main memory is divided into the two partitions. One is for the space for the operating system and the remaining spaces for the processes use that physical memory. So we have the different types of partitions method, that is a single partition and variable size partitions and multiple partitions. So in single partition means only one process and operating system space is allocated in the physical memory. So that physical memory address is assigned by in terms of the relocation register and limit register. Based upon that address, the physical address is assigned for the given page. So this is the thing will happen. Suppose the physical memory is allocated to the given process. So the CPU generated the logical address. So that logical address is compared with that limit of the register. If it is okay, means it goes to the relocation registers and find the corresponding physical address in the physical memory. Suppose that limit register is lesser, means it is produces an error. That error is reported to the operating system. So this production is done in the conversions of logical to the physical address. So in the contiguous memory allocation, we also have the multiple partition systems, because more number of processes are equally use that given physical memory. So we are dividing the memory into the several partitions. In multiple partition system, we have a fixed size partitions and variable size partitions. So each partitions is called it as a Suppose if the partition is not allocated to the any process means that is called it as a whole. So in the multiple partition, in fixed size partitions, we are using the static partitions. So the process suppose you are having a 4 processes means the physical memory size is 20 K means we are allocating allocating the space for 4 processes 20 divided by 4, so the 5K for each processes. That is a static partitioning. So that is a fixed and unequal partitioning. In the static partitioning, we having the equal and unequal size partitioning. The left side figure shows that equal size partitions are the physical memory. So I already know that in physical memory we have the operating system, we have space for the operating system and also the processes. So in the equal size partitions, here the equal size is given allocated to the all the processes. In the unequal size partitioning, we can allocate the partitions, we can allocate the space based upon the 2, 4, 6 and 8 based upon that. So it reduces the fragmentation problem. That is, a fragmentation means unused space problems we can reduce in the unequal size problem partitioning. In the multi-partitioning systems, that is a variable partitions, that degree of multi-programming is limited by the number of partitions in the variable size. So for the whole is called it as a block of available memory in the physical memory. So the whole of various size are scattered throughout the memory. When a process arrives, it is allocated memory from the whole large enough to accommodate it. So in the multiple partition variable sizing, we are having three types of dynamic memory allocation methods. That is that first fit, best fit, and worst fit, and also the next fit. So these are all the dynamic storage allocation is done in the multiple partition systems. So what is a first fit means? We can allocate the first available hole that is big enough for the given process. Next is the next fit means the same as the first fit, but we cannot do the search from the starting. We can search always from the last allocation file. Next is the best fit means allocate the smallest hole that is big enough for the given process. So we are going to do the search in the whole system, whole physical memory, and find the smallest hole for the corresponding process size. Next is in the worst fit, we can allocate the largest hole in the entire list, and we can search the entire list and find the largest hole and allocate that process in the given space. That is a worst fit algorithm. So these are all the memory storage, dynamic storage allocation techniques is done in the multiple partition methods. So this is the dynamic memory allocation algorithms. I already told that. Here first fit means first we are searching the given space and find the first available hole that is big enough. And best fit means search the entire list and find the smallest hole. Worst fit means search the entire list and find the largest hole. So next concept is the fragmentation. So what is the fragmentation means? The fragmentation is inability of reusing the memory that is free. We have the free space, but we cannot reuse the space for the given process. So the fragmentation is done by the dynamic memory allocations. So we have the internal and external fragmentation. So internal fragmentation is wastage within the partition is called it as internal, and wastage external to the partition is called it as a external fragmentation. So how we can solve that external fragmentation means using the method of compaction. The compaction is a process in which the free space are collected in a large memory chunk, and that to make some space available for process. So we are collecting all the free space and store it, and we can separate the memory space are the allocated and non-allocated space, free and occupied space. So that can be reduce the problem of external fragmentation. So internal fragmentation means there is a available space within a partitions. So the external fragmentation means available space across the partitions. So I hope that you will understand the what is the swapping and what are all the memory allocation, memory partition techniques, that is a fixed and a variable size. In the variable size partitioning, we are having that different types of dynamic memory allocation algorithms. So using the dynamic memory allocation algorithm, we have the problem of fragmentation on two types, that is internal and external. How we can solve the external fragmentation using the concept of compaction. Thank you.